Okay. Could I get my slides? Good. Well, super excited to see all of you here. This is the first time I'm giving this presentation, so you're getting all the alpha for the first time, and so you can front run everybody. Super excited to present Zero-G. It's the first modular AI chain, and we're focused initially on an infinitely scalable, programmable data availability layer so that true high-performance applications can actually be run on chain. And so I'll unpack a lot of that as we go along. But first, let me just introduce the team a little bit. So you've got myself. I started out on the technology side, started at Microsoft doing software development and technical product management, and then switched over more to the business side. Worked at Bain & Company, worked at Bridgewater Associates and TradFi, and then started my first Web 2 company, scaled that to 650 people, raised a bunch of venture financing, became a unicorn, top YC company, and so on. But went to a board chair role and left that for Web3 because I'm just having a lot more fun in Web3. And I've actually invested in my first Bitcoin in 2013, did a bunch of ICOs, and then more recently like WorldCoin and Uniswap and so on. So love reading white papers and super excited about now actually being an operator in this space. The reason I actually did it as well is because I met Ming and Fan through Thomas. Thomas is my grad school friend from Stanford. And he basically said, hey, I invested in this project called Conflux like 5 years ago, know the founders super well, you guys should link up, I think you'd do super well together as a team. Met up with these guys after 5 months of co-founder dating, basically determined that these are the best engineers and computer scientists I've ever worked with, and said, we have to build something together. Like it's the time, this is amazing. So just to give you a sense, Ming has been at Microsoft Research for 11 years, basically wrote a lot of top papers in distributed storage, like Tango and Curfew. He also wrote some of the first AI algorithms for Microsoft Bing. And then Fan was actually his intern at Microsoft Research, and that's how they met. And Fan, he was part of Andrew Yao's class at Tsinghua. Andrew Yao's like a Turing Award winner, and then met Ming, and then started doing his PhD at MIT, and kind of worked on Conflux right after he finished that, and became a professor at UToronto as well. Holds 2 Olympic gold medals in informatics, so I never want to challenge him to a coding contest. I definitely will lose, but so really passionate about the team, super fun dynamics. We laugh a lot. We love to build things. We played, so Hack is one of our lead investors, and they recommended like, hey, you should check out this game called Paddle. So we played Paddle together for our offsite, and it's like this super weird game. It's like tennis, except it's like squash, except it's like racquetball. And so it's like a bunch of things combined, but it was super fun. So we have a lot of fun together. And so really feel fortunate to have amazing investors. Our seed was 15x oversubscribed because of what we're doing. Delphi, one of our investors, thank you for being here. Nice to have you here. Obviously, really great people, Manklas, Hack, Gumi, many great companies that are part of the mix, and so super exciting to have them be on the journey with us. And so I mentioned this a little bit briefly, but basically experts on blockchain scalability, on AI, on distributed systems and storage, and so I've done a lot of research papers in this space, and are really excited about really implementing that research into production very, very rapidly as well. And so what is the core problem that we're solving? So this is something that we took a very first principles approach to. We were fundamentally thinking about what does Web3 scalability end up being? How do we get to Web2 parity, both from a performance perspective, but also from a pricing perspective? And so that was the first line of thinking. Because if we don't get there, how do we build true high-performance applications? How do you build on-chain gaming when you can't manage state, when you have state explosion? How do you build on-chain AI applications when you need a huge data availability pipeline in the gigabytes and that's not available? And so that was really our first thinking. And then the real key impact is that if you have n rollups over however many transactions per second, you need very large data availability space in order to actually build that. And so we basically set out on a journey to say, how do we actually make this possible? For example, I spoke to a project the other day, Manifold AI. They said, we want to do decentralized training. And I asked them, like, what kind of data pipeline do you need? And they were like, yeah, 50 to 100 gigabytes per second should do it. And so we're like, we're up for the challenge. We can make this happen. And so those were some of the conversations and thoughts that we essentially went through. And so one of the key use cases that we're supporting in partnership with Aura and Modular Labs as well is something called OPML and ZKML. So for OPML, first you need to actually store the model on chain. And that can be very large, tens of gigabytes with the latest Llama model, even hundreds of gigabytes in some cases. And then you need to serve the decentralized inference traces. So if you want millions of concurrent users, you're dealing with gigabytes per second in data availability speed. No DA system today is able to handle any of that. So how do we build a DA system for the future so that we enable this type of application? The second example that's pretty interesting is, so imagine you're trying to scale poker, online poker. Let's say you have 100 million users, which in kind of Web 2 world is actually not a lot. There's hundreds of millions of users. But you're starting to see that even there's just 3% saving and loading state, you're ending up with 120,000 gigabyte per day. Like, which DA layer manages that today? And so this problem is already real. So we've just recently chatted with somebody that works with DeFi Kingdoms. They have only 20,000 daily active users, but they're already managing a state of 14 terabytes. They're consistently running out of space. They're having issues. This is like a big, big issue for them. So how do we solve that? And there's many other use cases that need very large DA pipelines, so high-frequency DeFi, for example. Because in that use case, if you have a market maker, for example, and they're doing thousands, if not tens of thousands of trades a second, if the transaction cost just goes up by 20, 30, 50, 100%, their business model blows out. So how do you make sure that the transactions per second are consistently available and the cost is also consistent as well over time? Data marketplaces, ZK proving, decentralized IDs, RWAs with lots of metadata, all of that will require very large data pipelines. And so how do we do it? So this is the core architecture. So we start over here with essentially a DA blob that gets split apart into erasure-coded data chunks through a dispersed server. And we hyper-optimize that as well. We can talk about that later. So that gets them put onto this storage network. And we built a complete storage network from scratch. And so we support all Web 2 data types in this. You can completely customize it, whatever the replication that you want, whatever the storage location is that you want, however, what the data persistence is that you want, we can basically customize all of it. But these chunks then get split across some of the nodes on the data storage network, not all of the nodes. And so that then creates an aspect of horizontal scalability from a node perspective. And so as that is happening, we're also doing validity proofs in KZG commits to basically prove the validity of encoding with a separate consensus layer. Now, instead of using light clients, this consensus layer also does the data availability sampling, lots of nodes independently. Once they reach consensus that the data availability sampling is done, you're basically then writing a ZK proof to the underlying L1 saying that, yes, this block is actually available. And then there's also some management of incentives, basically storage rewards and the storage proofs as well. So that's the core architecture, and that's how we're able to drive a per node speed of about 10 megabytes per second. And then with horizontal scalability, our consensus layer should handle about 5,000 nodes or so. So you're dealing with about 50 gigabytes per second per consensus layer. And so what does that mean? Like if you compare ourselves to anything else that's available today, like on ETH, you're getting 0.08 megabytes per second. So horrendously slow, very slow data throughput, makes things super expensive. L2, a little bit better. Dank sharding starting to get better. You've got Celestia, Eigen starting to get better. Then you've got Solana Firedancer at 1.2 gigabytes per second. And then a huge uptake for truly high performance applications. And then we look at the cost perspective as well. You've got alt DAs costing about 13,000 or so per gigabyte per month. Some other ones that are a bit cheaper. And then you start going to Web 2 speeds. You've got AWS SDs AWS S3 with SSDs and AWS S3 without SSDs, and then you've got us. So with this pricing, we finally get to Web 2 parity in terms of pricing and performance. And so that's super exciting. It'll open completely new application spaces. And so we also don't want to stop there. We're also introducing the first programmable data availability layer. So what does that mean? So what you can do essentially is you can save a state through a smart contract, and we handle the rest. So if you wanted to, for example, as a gamer, use Arbitrum and say, okay, I want to save my game state, and I'm running out of gas fees, I'm going to Polygon, you can load your state again, and then keep playing, for example. So lots of cool stuff can be done with this, and completely program it. I won't go too much into the details, because the concept's pretty straightforward, but we can chat about more if you have questions. So the other thing that we're introducing that we're super excited about is this concept of infinitely scalable DA. Because what we found out in our research is that not only does the node network scale, but you can also scale the consensus networks. And this is possible because we have a completely separate data storage network. So each one of these consensus layers can interact with the storage network at the same time. And then all of the gas tokens essentially are mapped to one overall ERC20 token, and the entire network is then secured via restaking. And we can do that through EigenLayer and Babylon and other providers as well. And so this is super exciting, infinite data pipeline. And the other thing that's possible is you can actually dedicate individual consensus layers to a specific chain. And so now you can basically count on DA pipeline. So if you're a high-frequency DeFi provider, or somebody like Layer N, for example, you can guarantee to your users that your gas costs will not rise because you have complete DA pipeline only to yourself. And so the other thing that we're introducing that we're super excited about is this concept of aggregated DA. So with this, what we can basically do is we can take a data blob and then aggregate all of the different DA layers, Celestia, EigenLayer, and so on. And then you can choose, as the end user, do I want to run this in high performance mode? Do I want high security mode? Do I want do I want a backup DA? So you could have a primary DA and a backup DA, for example, and kind of choose your configuration, if you will. And so super excited about this. So what does this allow? 100% uptime. Allows for load balancing. Allows for really loading and saving state to anywhere, NEO1, NEO2. And it's really great. It's a collaborative spirit. That's why I'm in Web3, because I don't think there's like true competitors in Web3. So it's super fun. And so this is my attempt at putting a very nerdy dad joke on the slide. So if you're not laughing, I know it's not working. So basically, the idea is that if you have an infinite consensus, you're adding a storage layer, and you're adding aggregation, that it's like modularity squared. And so anyways, so basically, you have maximum performance on-chain AI and gaming as part of that modularity squared. So you guys can give me feedback. If this is not funny, I will take it off the slide. So maybe after in the questions. Okay, so back to the AI use case. So where do we play? Some people might ask, like, well, do you support decentralized inference networks and so on? Of course we do that, but we partner with others to do that. What we do is really provide the data availability infrastructure, we provide the model storage, and then the execution piece is done through partners. And I'll go to the partners in a second. So we've got, on the execution side, we now support things like AI agents, autonomous smart contracts, ZKML, and so on. And so here are some of the partners that we're doing it with. So for example, Aura does OPML. As I mentioned, you store the model on chain, and then we support the decentralized inference traces. Modulus Labs does ZKML, so the use case there is a little bit different. You store the data used for the kind of compute on chain, so it's publicly verifiable. Because you can verify the compute, but you can't easily verify the data that was used for the compute. And so it can even store your training data and so on chain. And definitely making a strong push kind of in the AI side, but Also making sure that we're supporting really strong layer 1s and layer 2s as we're building, and then of course distribution through some of the roll-up as a service providers. And so this is the first time I'm also sharing our timeline in terms of how we're going to execute. So public testnet is happening in 2 weeks. So be ready for that. We're starting to put documentation online. Our private testnet tests have been going really well. And so stay tuned for that. Mainnet phase 1, end of Q2. And then mainnet phase 2, planning for end of Q4. So those are the key milestones for us. And then the key features that we'll have are, first of all, the infinitely scalable DA piece. Then we'll move on to actually implementing dedicated DA, aggregated DA, and then also doing things like programmability and restaking, and doing kind of deeper AI model support once we get to 2025. And then many different pieces on the roadmap for the community as well. And so how do you get involved? So definitely join our social channels. We'd love to hear from you in terms of what you want to build at the intersection of Web3 and AI. Also, our draft Gitbook is online, so take a look at that. Give us some feedback before it goes, fully live with the public mainnet. And then we also have a bounty. So we will pick the 10 best tweets where you share about what the application spaces are that you want to explore at the intersection of Web3 and AI. And we'll do the same thing for the top 10 blog articles that you write as well, where you talk about what you want to build at the intersection of Web3 and AI. So super excited to be a sponsor here. So thanks everyone for definitely being a part of this and enabling this great space for builders and the community. And so that's basically it. You can follow me on X as well. You can reach me via email. I don't know if that's easily visible from where you are. My TG, Captain Von Kirk. You can probably tell I'm a Star Trek fan based on that handle. And yeah, my X and our website. So thank you. Okay, real feedback. Was the joke funny? It's okay. All right, good. Thank you. All right. So vote of hands. Take it off the slides. Anybody wants me to take it off the slides, like that particular joke? It's fine. Okay. Leave it. Thanks. I love that. Love the love. Sorry? Yes. Yeah. We're planning on releasing a token as well. Yeah. We're planning to hopefully have exchange listings before during Q3. Yeah. Still determining the exact date, but before then, yeah. Yeah.
Hey, Michael, just thinking through the poker example, if you have a large on-chain model running that poker site, and crypto people are worried about their money getting stolen, what type of security guarantees take place here at Zero Gravity?
That's a really interesting question. You probably have to have an AI agent actually monitor the security as well. So we could build that in from a security standpoint. And then the consensus nodes themselves are secured through restaking, and so we can buy quite a bit of economic security that way. So I think those two specific things, and then can always monitor for kind of DDoS attacks and those types of things as well. Yeah, yeah. Yeah. So we're planning on doing a point system, so incentivized kind of testnet and so on. And then because we're working with a lot of infrastructure providers like layer 2s and layer 1s, through there we will get application developers on top. And then we're also getting a lot of organic traction already from projects coming in and saying, hey, I want to build on this AIDA because I'm writing a game and it's using an LLM to generate the world, and I just want my model storage to be with you and then also have the inference traces served by you as a result. And so it's an all-in-one package. And so that's a perfect use case. There would be a roll-up essentially. And then through the RAS providers as well. I think those are kind of the key ones. Anybody can join, yeah, it's trustless. Yeah, it's fully decentralized, trustless storage node. And you can decide as a node operator if you want to just run a storage node or if you want to run the storage and the validators. Could be one machine, multiple machines, really up to you. The goal for us is to use commodity server hardware. So I think right now we're looking at minimum requirements of probably 8-core CPU, 16 gigs RAM, like a terabyte SSD, something like that. We are hiring and bringing on board AI experts, so potentially, but not exactly sure yet on that. We probably work with our partners on that, like through like Exhibits or like IONET or somebody like that. Yeah.
And Michael, what are the sort of stakeholders you have to incentivize here? Storage nodes, I think you said consensus nodes.
Yeah, validators, yeah. Yeah.
Parties primarily?
I mean, it could be all in one machine or same providers can do both, essentially. Yeah, so just different rewards. Once more the storage reward, once more the consensus kind of reward, yeah.
It'll be funny if IONET starts using you guys, reverses the flow.
I was just chatting to the founder this morning, so yes, very possible. Cool. Other questions? All right. Well, thanks for listening.